Hey seniors, today we're going to be talking about linear and nonlinear functions through equations, tables, and graphs. All of this is going to be reviewed from the last couple of days. Today is just going to be the day that we put it all together. So on your notes page, go ahead and write linear and nonlinear functions in the top left-hand corner. And then let's remind ourselves what a function is. A relationship is a function if every x value has only one y value. Write that in your notes page. I know it's getting repetitive, but I want to make sure that we have it down so we don't forget. So Shivance, make sure you have this written down. And then a non-function is a relationship where x values have more than one y value. I'm more interested that you know what a function is. All right, guys, let's start with linear versus nonlinear equation review. All equations in slope-intercept form, and of course slope-intercept form means in the form y equals mx plus b, are linear. They are also all functions. And I know equations are linear if there are no exponents in the equations or variables in the denominator. So if I were to have y equals 3x minus 6, this equation is not only linear, it is also a function. So this would be referred to as a linear equation. Also, if I ever had the example y equals 3, I know that whenever I see y equaling a number, it is always a function. It is also always linear because I could draw my line through it, my vertical line through it, and every x value would only have one y value throughout. Make sure that those things are written down in your notes page. We're going to be coming around to check. Now let's talk about nonlinear function equations. It is very possible for equations to be nonlinear, but to also be functions. So if I were to have the example y equals x squared plus 3, make sure you have this written down in your notes page. I know because of the exponent that it is nonlinear. However, I know that this is a function because I could plug in any number for x. It could be, like I could plug in -1 or 1, and it would still give me the same y value because any number squared is going to give me a positive outcome. So I know that even though this is nonlinear, it is a function. So this would be referred to as a nonlinear function. We're going to get tons of practice with this throughout, so make sure that that one's written down on your notes page. Okay, guys, let's look at these graphs. I know that straight lines are linear, and everything else is non-linear. So this graph here on the left is going to be my only linear relationship. The rest of these are going to be non-linear. My next step is to figure out, are they functions? Well, I know that when trying to determine if graphs are functions, I can use the vertical line test to figure out if every x value has only one y value. So I'm going to go ahead and draw a line through my straight line. Yep, it only hits the graph once, so this is going to be a linear function. Now, my sideways parabola. If I draw my vertical line, I can see that it hits my graph twice, which means that for every x value has more than one y value. So this is not only nonlinear, it is also a non-function. So that NL/NF just means nonlinear / non-function. Now, our straight up and down parabola, I already know that it's nonlinear because it's in the form of a parabola. It's not a straight line. If I draw my vertical line through it, I see that it only hits it once, which means this is a nonlinear function. Now, let's look at our V-shaped graph here. I know it's nonlinear because it is not a straight line, but I know that it is a function because if I draw my vertical line through it, it only hits the graph once, which again means that this is a nonlinear function. Now, the best way to approach these is, again, go through and figure out first, is it linear or nonlinear, and then whether or not it is a function or not. Okay, guys, let's talk about tables. Tables are linear or nonlinear based on whether or not the slope is consistent throughout. Make sure that's written down in your notes page. You must find the slope. Tables are functions if every x value has only one y value. And the way that we figure that out is, again, if x values repeat, means it's a non-function. If x values do not repeat, it's a function. All right, let's go ahead and do an example. All right, guys, make sure that this table is written down in your notes page. So again, the first thing I'm going to go ahead and look through is to figure out whether or not this table is a function. And again, all I have to do to figure out if this table is a function is to go through and see, do any of my x values repeat? Well, let's look at our x values. -2, -1, 0, 1, and 2. Okay, none of my x values repeat, which means that this table is a function. Now, my next step is to figure out whether or not this table is linear or nonlinear. And the way that I figure that out is to see if my slope is consistent throughout. So it's going to be change in y over change in x. So I'm going to have, this is a review skill, we should be very strong with this, -3 minus -7 over -1 minus -2. Now, if I keep change on top and bottom, it becomes -3 plus 7 is 4, and then -1 plus 2 will give me with 1. So I have a slope of 4 throughout. Now, let's see if that holds. To get from -7 to -3, it's going to be 4. From -3 to 1, also 4. 1 to 5, 4. 5 to 9, 4. -2 to -1 is 1. -1 to 0 is 1. To get from 0 to 1, it's 1. And 1 to 2, it's also 1. Now, can I divide any of these at any moment and get 4? Well, I know that 4 divided by 1 is going to leave me with 4. 4 divided by 1 on this side will leave me with 4. So yes, this table is linear. It's also a function. So this table is a linear function. Okay, guys, the last thing we want to do here is to figure out if the following coordinates are a function and to figure out if they're linear or nonlinear. So what I want to do with these set of coordinates is to set them up in an XY table. Very simple. We're just going to do the first few just so we get the idea. All right. Now, let me look through and see immediately, do any of my x values repeat? -2, -1, 0, and 1. None of them repeat, which means that this table is a function. Now I need to figure out, is it linear or nonlinear based on the slope throughout? So that's going to be change in y over change in x. So I have 1 minus -4 over -1 minus -2. Keep change. So I have 5 over, keep change, -1 plus 2 is going to leave me with 1. So I have a slope here of 5. So let's see if that holds. -4 to -1, in order to get there, that's going to give me 5. 1 to 0, that's going to be 1. 0 to 1, that's going to give me 1. That's actually going to be -1. -2 to -1, that's going to give me 1. -1 to 0, that'll be 1, and 0 to 1, that'll be 1. Now, can I divide any of these numbers at any moment and get 5 for my slope? Well, 5 divided by 1, that'll give me 5, so that one works. 1 over 1 is going to leave me with 1. So since the slope here is not consistent throughout, this set of coordinates is going to be a non-linear function. All right, guys, lots of information today. We're going to get a lot of practice, so let's go ahead and jump in.